Hi everyone, today I'll demonstrate another example to explain the usage of solver. In this case, we have to maximize the profit by fixing appropriate price for a product. What we have is the past data showing how the sales is affected by the variations in the product price. So this is past data. So based on the past data, we should be able to predict the sales for a given price. I am assuming the sales is a linear function of price. So how do you predict the sales? So to predict the linear variation, we have the trend formula in Excel. So sales you can predict here. So I'll type equal to trend. I'll select trend. So we need to select known Y values. This is a sales, comma, known X values, that is a price, then comma. So you have to give what price you need to predict the sales. So I'm going to enter the price here. So I'll select this cell, then close the bracket, enter. So I'm not getting a value here. If I enter some price, say for example I'll enter 700, you will get the sales predicted. So for 700 rupees approximately it is predicting the sales as 912. So that is by considering it as a linear variation. If it's a parabolic variation also we can do the prediction. You can use a dynast function to find out the parameters and then calculate the sales using that formula. But in this case, I am using a linear function to predict the sales, so based on the price. Now, the cost of each product is 500. So the basic cost is 500. If price is 700, so that difference between the price and the cost, that will give the profit. So 200 is the profit in this case. I have also constraints. The price of the product cannot be too high, so I'm just limiting the price to less than or equal to 1200. And I don't want the price to be too low also, because 500 is the cost of the item. So I need some profit. So at least the price should be 550 or more. Okay, so that there will be a profit of 50 rupees. So between this 550 and 1200, the price should fluctuate. And you should find out what will be the maximum profit out of this. What price you need to fix to get a maximum profit. So profit I am going to calculate here. How do you get the profit? Price minus cost multiplied by number of units sold. So sales I am getting here. So price minus this cost multiplied by sales, that will give the profit. So I'll write the formula here. So this is going to be our objective function. So equal to, I'll put the bracket, price minus cost. So that will give the profit multiplied by the number of units sold. So that will give the profit. So in this case, if 912 units are sold at a price of 700, the profit will be 1,82,400. But I want to maximize the profit. So how do you fix the price? What price you should fix so that you will get a maximum profit? That can be calculated using the solver. I'll use the solver. In the solver, you need to first set the objective. So objective is profit. So you can select this cell. Then now what you want to do? You want to maximize, minimize, or set a value. So in this case, you want to maximize the profit. The profit should be maximum. So it's already selected here. Now you have to change the variables. What is the variable you can change? Price you can change. So price if you change, automatically sales is calculated and you will get the profit. So only variable which you want to change is the price. So I'll select this cell. So here I'll select this particular cell. So I selected that cell, that is I15 cell, and now you need to add these two constraints. You can use the add. Constraint is price. Price should be less than or equal to 1200. So I'll select the price. Constraint you can select from here, less than or equal to 1200. So that you can add. One more condition is price should be greater than or equal to 550. So price is here. greater than or equal to, you can select. So the value is 550. So there are two conditions. So once you finish with all the constraints, you can click OK. Now you can see that these two constraints are already added. So these two constraints are I15 cell less than or equal to 1200. That is, price should be less than or equal to 1200, and again the same cell greater than or equal to 550. These are the two constraints which you are giving. Then you can select the GRG nonlinear, that is already by default it's there. Now you can go for solve. So I set the objective function, I set a variable. By adjusting this variable, that is a price, I should maximize this. It's given for maximizing subject to the two constraints, that is price less than or equal to 1200 and greater than or equal to 550. Now you can go for solve. So solver has converged to a current solution. So all the constraints are satisfied. So you are getting the profit here. So you want to keep the solver solution. So click OK. So you got the profit. And the price should be fixed at 1130, and you will get a sales of 542, and out of that profit will be so much. So this is the maximum profit you can get out of the sales. So this is by assuming a linear variation for the sales based on the price. So this is approximately linear variation. If it's a parabolic variation, you can use the Linus function and get the coefficients and then calculate the sales using the formula ax square plus bx plus c, where a, b, c constants you can find out and get the sales, and then in the same way you can find out the maximum profit. That's all in this class. Thank you for watching, and we'll meet you soon in the next class.